One section from chapter 2. Wow. That's terrible. Oh well. We'll make it work. To get any further, it's not going to reach. All right. Could be worse. Could do that. All right. So you guys, we have one section out of chapter 2 to do. Yeah.
If you circled like a word, does that mean my word is wrong, or is it? I don't know.
Just see me after if I'm not clear on what I meant. Yeah. Okay. Somebody had a question about finding class width on Instagram, right? How do you find how wide your classes are going to be? What steps do you have to take? Yeah, find the range. How far does your data go? From what to what? Find that range, right? So if it's 10 to 80, the range is 70. The highest data point minus the lowest data point divided by the number of classes you want to use, right? So how much distance you got divided amongst each class tells you how wide each class has to be, so you cover that much altogether. So you can actually, it makes physical sense, believe it or not. Math doesn't do that all the time, but yes, in this case it did. So we're going to do one last section out of chapter 2. And then we're going to do some work on the calculator. So if you didn't bring your calculator, just follow along. I got some, but they need some new batteries. My whole bag just needs new batteries, so I got to get some new batteries. The last time we left off, we did 2-4. Which, if you remember, was just dot plots, stem and leaf plots, scatter plots. So compared to the rest of chapter 2, I think 2-4 should be pretty straightforward.
I have a question on the scatter plots. One of the questions in the homework was like tar versus like CO2 emissions for cigarettes. Now a lot of the data was always the same point you would land on every time, like 20 to 16. So that's one dot and it represents like 6 or 7 different data points, right?
Exactly. Yeah. It's just that if you're going to do like an analysis of it, you would count those points. You'd have to put them all in it, like to find an average or something. You wouldn't want to just represent it once. Visually, though, you're right. You're not going to make like a topographical where it's just the texture is different there. You can't do that.
Right.
It's just the one point, right?
On the stem and leaf, also I noticed in the book that they used like the numerical values, or like as I was going through the data, crossing them off. Is the shape of it is more important, right?
Yeah, it's organizing your data, and the shape of it is a quick histogram type visual display. Yeah.
But does it matter the order you put the numbers in?
If you don't want to sort it, no, it doesn't matter. Because, yeah, but you could sort it, and then that helps you sort things too. So the very first thing we're going to do with the calculator when we get to that point is learn how to sort data, because that's the most obvious, quickly useful thing. Because it kind of sucks trying to cross out your data. Some of us forget data points. So we just put all the data in the calculator and just tell it to sort it. That would make histograms easier to do and all that kind of stuff. So I definitely want to do that before next time when I give you that quiz, because if you get a calculator between now and then, and I'll have my calculators with batteries, so if you need to borrow one, you can. It'll make that histogram problem easier. You just put that in, you can sort it, go from there. Any questions from what we did last time? Any other questions? That was the dot plot and all that. Feels like a long time ago, yeah. A lot's happened from then to now. Football season suddenly is now over. The Celtics won Sunday too, yeah.
Can you explain how you do the dot plot instead of the dot plot?
Dot plot?
Yeah, like.
Now that's, if you did a dot plot of the data, that's where repetitions definitely show up. So the whole purpose of a dot plot, so if I had like resting heart rates for people, like 60, 65, 60, 65, 65, 70, 60, blah, blah, blah. A dot plot would say, okay, I got 60, 65, 70, whatever. So I have 160, 2 60s, 165, 2, 3, and I got 3 60s here, and a 70. I mean, it's trying to show me where my data seems to be clustering. So if I say these are the resting heart rates, and then I take the heart rate again after we've jogged for 20 miles, I'd expect my resting heart rates to cluster here, and my jogging heart rates to cluster up here, right? I'd expect, of course that would be true, because we've already seen that, but we could do similar. We want to see where does the data cluster. Maybe for one city it's here, and for another city they cluster there. Why the hell are they clustering differently? Are they eating differently? What do they do? So it's a real quick visual of my data again. So 2.4, that's the whole idea of 2.4 is quick visualizations of my data that by themselves help me figure out which direction to go, what to study with my data. Okay, cool. So 2.4 really should be pretty straightforward, especially because I cut out some of the stuff that we really don't use that often, like ogives, frequency polygons. Yeah. And 2.5 is only like chapter 1 in that it's another kind of common sense section. So let me give you an example. Look on page 72. Or even better, so let's start with 71. That's a little more direct to the point. You see for the booklets up there. Like the booklets. So what 2.5 is all about. Room is set up so weird. In 2.4, we talk about how to visually represent our data, right? 2.5 then comes back and says, okay, now we see how to visually represent it. Let's talk about all the ways that somebody could consciously misrepresent data, right? Because that's the thing about statistics, you know, the lies, damn lies, and statistics. Have you guys ever heard that? I mean, statistics can definitely be consciously misused. That doesn't mean that it's got no purpose. It doesn't mean we have to throw it out entirely just because people can misuse it, right? People can misuse cars, but thankfully they haven't thrown that idea out. I still have a car, right? So on this page, this is a very, and again, they're making it a little more obvious, but just to make a better point, which one of those graphs is actually more fair? Yeah, what's wrong with the first one? Why is the first one unfair? And some of you guys might realize that, I mean, the first thing I think of when I see that question was that Terry, how do you say her last name? It's Terry Schiavo case a while back down in Florida. You guys, how old were you guys when that was happening, I wonder? Had any of you guys ever heard of Terry Schiavo and the feeding tube? And she had, the state she was in was under question. So you can imagine, these guys are trying to overstate the difference in opinion, aren't they? Whoever created this graph is trying to overstate the difference in opinion. And how can you tell that? I mean, if you just look at that, don't even look at anything else, and go, holy crap, look at the Democrats. They want to kill this person. I mean, that's the immediate reaction I would have, right? And why is it skewed? What tells you that it's actually been skewed? Yeah, they start at 53. And the scale is so small that it's going to overstate. If you have a better scale, start at 0. You can see that overall that those differences really aren't that big. This still might not be perfect, but this is definitely a conscious decision somebody made to try to overstate that difference. So you see that kind of thing a lot. People sneak that by all the time, and nobody ever questions it because people don't even know to look for that. They just go, holy crap, look at that! You're crazy people. No, go ahead. Now over here is something that's a little less obvious, possibly. Okay, especially if you can't see the whole thing. But when you use, for example, when you use anything that has area or volume to represent something. So here, from 18,000 to, let's say, 51,000, that's almost, not quite tripled. So see how that side length is maybe 3 times as long? So you see like 18 to 51, triple 18 is 54, so it's about triple that side length, right? Are you guys with me? But what did the volume do? If you triple a length of a side of a cube, that means every side just got tripled, right? So the volume got 3 times 3 times 3 times bigger. They got 27 times bigger. So again, you're overstating the differences. Do you guys see what I'm saying? Or they use money. Very often they'll use money to evoke an emotional response, right? And it's area too. You see, every one of these bills has area to it. So again, it's doing the same thing. It's double the size, but you also have an emotional response. Money, you see a dollar bill, like, don't take my money. Ah, you know? An immediate emotional reaction without just looking at it objectively. What does the data actually say? So this section is going to be all about what's wrong with the data as it's presented, and it's also going to be about redraw it so that it's better, so that it actually is less misleading, right? So for example, what's the first thing you could do with this, number 6?
Start the scale.
Yeah, start the scale at 0. So that kind of thing, and that's why I say this section really should be a common sense. You can do whatever you want to with this section, but it should be a common sense section. And it should be nothing that's too hard. I mean, it should be pretty straightforward, I would think. I'm trying to remember if there's anything else they talk about. I think that's the main things. Pictographs, using objects, like they use oil barrels when they're talking about how much the price of oil has changed. Something to evoke a response from a part of the brain that we shouldn't be using when we're trying to look at just data. I love this one. What the hell? So this is kind of like a 3D, like a curved pie graph, which is really just no good. You can't really get a good feel. You want it to be 2-dimensional. You got it over this dude's head. Who is that dude? Just some arbitrary CEO.
Dr. Phil.
Is it Dr. Phil?
That's who I thought.
Sure, he's got a lot of money. Why not? Just somebody, and you're sitting there going, "You bastard! You got all this money." So possibly, I don't know who this guy is. But most of them are going to be stuff like you got something with volume going on. Can't really use volume if you're going to change just the length of a side, because it's going to affect the volume more than you think. Or it's got scale that's bad. Very, very obvious things. So that's what section 2.5 is all about, is making sure you understand the things to look for in a graph. Okay. So that definitely should be quick. So now today I really want to get into some meat. And if I'm new in this class, I'm a little worried, because we have chapter 1, which is nothing but definitions. We have chapter 2, which should be, for the most part, pretty straightforward, easy, but it's not necessarily the most interesting stuff in the world, right? It should be pretty easy. So now finally chapter 3 is where we really get into the nitty-gritty, real meat of statistics. We see our first few equations, which some of you guys are like, I'm okay with the boring stuff, we don't have to go there. But we're going to go there. We see our first major concepts. Sure, let me keep this up here. So let's start. Let me just see what you guys already know. What's the mean of a set of data?